Hello guys, welcome back to my YouTube channel. So today we would be discussing another most asked Google interview question. So the question is count k subsequences of a string with maximum beauty, and it has what difficulty as hard. So let's go into the question. So question states that you're given a string s and an integer k, and a k subsequence is subsequence of s having length k and all its characters are unique. That is, every character occurs once. Let Fc denote the number of times the character C occurs in S. The beauty of K sequence subsequence is the sum of Fc for every character C in the K subsequence. For example, consider S A B B B D D and K is equal to 2. Fa is 1, like total number of count of A in given string is 1. Fb is 3, so B is present 3 times, and Fd is 2, so D is present 2 times. Some K subsequences of S are these. These are subsequences. Return an integer denoting the number of K subsequences whose beauty is maximum among all K subsequences. Since the answer may be too large, return it modulo 10 to the power 9 plus 7. A subsequence of a string is a new string found by the original string by deleting some, possibly none of the characters without disturbing the relative positions of the remaining characters. Notes Fc is the number of times a character C occurs in S, not a K subsequence. And two K subsequences are considered different if one is found by an index that is not present in another. So two K subsequences may form the same string. So let us consider the example of this. So given string is S and K is given as 2. So we would require so we want maximum subsequences, so we will take only those characters which have maximum occurrence. So here in this case we will take C, and we might take B or we might take A, because both of them have occurrence 1 only. So we will have to take C, and we might take B and then A. So one of the subsequence can be 0 1 if we pick this B and C, another can be 0 2 B and C, other can be 1 and 3 if we pick C and A, and another can be 2 3. So that is why the answer is 4. Again, if we go to example number 2, so A B B C D and K is 4. So in this case, like there are only 4 characters which are different, so we will have to pick all the 4 characters. So either we can pick 0, then 1, then 3 and 4, or we can pick 0 2 3 and 4. So the answer will be 2. So S length is given as 2 into 10 over 5, so only answer up to n log n is acceptable, and K can go from 1 to S total length, and S consists only of lowercase English letters. So this is the question that we are given a string and we are also given an integer k, and we have to find the k subsequence of the string s which have the maximum sum of f functions. So f is like how many times this is occurring in the original string. So I think let's consider one example and then we can see how we'll calculate our answer. So suppose the given string is this A, B, B, C, C, D, D, E, E, and K is 3. Let me take out a pen. So this is our given string and K is given as 3. So here we can pick only 3 characters. So here we would obviously want to pick character A because it has the maximum number of occurrences. So it will increase our answer. So this would already, like this we will pick, and then we will have to pick, like BB has 2 times, C is occurring 2 times, D is occurring 2 times, and E is also occurring 2 times. So out of these 4 B, C, D, E, we have to pick 2 more characters, but all of them have same occurrences. So what we will do is like in order to create subsequences we can pick A. So A can, like we can pick any occurrence of A, so that is why 3 is coming here. Then we can pick, then what we will do is, like we will have to pick 2 characters more because K is 3, we have already picked 1, so we need to pick 2 more. So either we can pick BC, we can pick BD, we can pick BE, we can pick CD, we can pick CE, or we can pick D. So there are 6 ways, so that is 4C2. Like out of these 4 we have to just pick 2, so 4C2. multiply by, and the suppose we pick B and C. So B is occurring 2 times, so we are multiplying the answer by 2 times, and C is also occurring 2 times, so number of sequences will be multiplied by 2 times. So this will be our final answer. So in this way we will calculate our answer, and I hope you have understood the algorithm. So let's jump on to the coding part of it. So initially we will say that if k is greater than 26, so there cannot be character more than 26, so in that case answer will be 0. Otherwise we are calculating n as the s dot length, and we are also defining mode, and here ll is we have defined ll as long. So mode is defined, and then we are keeping count of all the characters. Like we have defined a array of count with 26 characters, and each character will store a count of how many times it is occurring in s. So we'll iterate through s, and will increment for each of the iteration. We will increment that corresponding character count by 1. So this count will store each of the characters count. So suppose for our given example, this count for 0, because a is occurring as first, so count of 0 will be 3, count of 1 will be 2, count of 2 will be 2, count of 3 will be 2, count of 4 will be 2, and for other count 5, count 6, those all values will be 0. So then we will sort our count, and then we will also reverse, so that it is like our count is in decreasing order. So then what we will do is like we will iterate our, like we will define our answer as 1, and then we will iterate from I less than k, like k times we will iterate from starting, and we will multiply the answer with our answer, because here also we are doing the same, like k is 3, so we will multiply here 3, then we will iterate 3 times, so 3, then here we will be multiplying 2, and here also we will multiplying 2. So first we are calculating this portion of our answer, like this portion we are calculating first. So here like this will be calculated, and we are also taking mode, and then we are storing what is the value of at k minus 1. So what is the value at like this will be the value, so 2 will be the value in our case. And then we are seeing, like basically we want to calculate now how many, what will be the value of this, and what will be the value of this. These two values we want to calculate, so that we can take the NCR. So in order to calculate the values, what we will do is we will store its, so at kth position we will store the count, that will be 2, and then we will start our loop from starting, and whenever we encounter 2, then we'll count how many 2's are present, and so that will be our this value, this superscript value. And for calculating the subscript, we will have to check like how many characters are present inside our given k. So for this what we are doing is this covered will store uh, this covered will store how many characters have already been covered. So in our case covered will be 1, and current will store like how many total current characters are present with the same count. So current will have value of 4. So we'll iterate, and if current is 0, then what we will do is we will check if count is equals to temp, and if it is equals to temp, then we will set covered as I, and curve will increase by 1. Else if it is not 0, then we will check if count I is equals to temp, then we will increase our curve, and otherwise we will break out. So we have to calculate our answer into NCR. So this is a function which we are calling in order to calculate NCR. So this is the value of n cur. So this is the value of n, this is cur, and for calculating R we will have to take k minus covered, like how many have already been covered. So 1 is already covered and k value is 3, so our answer will come as 2 here. So in this way, and we are also passing the mode value for which we want to take mode. So in this way we will calculate NCR, and in order to calculate this NCR, like you can go through one Geeks for Geeks link, like compute NCR modulo P using Fermat-Little theorem. So I have just copied the code here in the above section, from this page only, so you can go through it. I will attach the link of this Geeks for Geeks article in the description of my video. So yeah, you can go through it and then you can understand how we can calculate NCR mode P. So yeah, then we will return our answer. So this should work, I think. So let us also check what is the time complexity. So here we are going on, and here we are taking O26 log 26. Here we are going on, and here also we are going on. So it is kind of on. Yeah, it is, and this NCR will also take on. So this is a kind of on algorithm. So it should pass because n is 2 into 10 to the power 5, and you can see as 2 into 10 to the power 5. So let's run our code and check whether it's working fine or not. So we are running it. So yeah, it is got accepted. Now let's submit it. So yeah, it's working fine. So I hope you have understood the solution. So I'll attach the code link and this code, complete code, in the comments, and I will also add this our calculation of modulo NCR modulo P link in the description of the video, and I will also attach the problem link in the description and problem description also in the video description. Like this description will also be added. So yeah, I hope you like my video, have understood the explanation to the question. So do like this video and subscribe to my channel for staying tuned for upcoming more important data structure and algorithm questions. So yeah, stay tuned for more such questions, and yeah, have a nice day.